Okay, so welcome to the full GCSE Statistics course. We are now on chapter 6. This is section 11. This is a small one and it's about the formula for conditional probability. Keywords we're coming across are conditional and independent. Let's just quickly recap on what conditional probability is. Two events are conditional if the outcome of one event affects the outcome of another event. Okay, so the two events are linked. So let's go on to this lesson. First key point, the formula for the conditional probability of B given A is... Okay, let's go over what this means. So the probability that B happens, given, the line means given, that A has already happened. Right, this could be, A could be that it's raining. What's the probability someone takes an umbrella given that it's raining? Something like that, okay? So probability of B happening given that A has already happened is probability of A and B divided by the probability of A, and that's the formula you need to know. Now, it's always the second letter, the given is always the divided one, and it's always A and B at the top. So just to kind of put that in reverse, we could have the probability of A given B, and that would be the probability of A and B divided by the probability of B this time. Okay, so it's always the given one is the denominator in this formula. And I'm just delving in a little bit more detail here to kind of give you a really good idea of what A given B and B given A means. Here's a tree diagram. This would be the probability of A given that A has already happened, okay? This would be the probability of B given that A has already happened. Probability of A given B that's already happened, and the probability of B given B has already happened, okay? So that's what this given means. Okay, so how do we answer these questions? Number one, you learn the formula. At school, 5% of students are female and in year 10. A fifth of all students are in year 10. A student is chosen at random from year 10. What is the probability that they are female? So let's just write this out. The probability female and year 10 is equal to 0.055%. The probability that they're in year 10 is equal to a fifth, so 0.2. A student is chosen at random from year 10, so they're chosen from year 10. What is the probability that they are female? So we're looking for the probability that they are female given that they're in year 10, because we're told we have chosen someone in year 10. So they've given they're in year 10, what is the probability that they are female? So female given year 10. Right, in your formula then, so it's the two and, it's the both of them happening to start with. So it'd be the probability of female and year 10. And you are dividing it by the probability of the given one, the probability that they are in year 10. Okay, taking the numbers that we've been given would be this then. So probability female and year 10 was 0.05. Write this out in full. Probability of female given that they're in year 10 is 0.05 divided by the probability that they're in year 10, which is 0.2. 0.05 divided by 0.2. 0.05 divided by 0.2 gives us a quarter. And that's your answer. A student is chosen at random from year 10. What is the probability that they are female? It's going to be 0.25. Okay, a quarter. Right. We can use this formula as well to check for independent events. If we think about this, the probability of A happening, right, would not matter if B had happened. So the probability of A is just equal to the probability of A given B that's already happened, because it doesn't really matter what's happened with before. They're independent. They don't affect each other. So if two events are independent, then the probability of B happening given that A is happening is exactly the same as just the probability of B happening. They're completely unaffected. And we can use this formula to effectively check for independence, okay? So if we said this, that the probability of A and B happening is equal to 0.3. The probability of A happening is equal to 0.6, and the probability of B happening is equal to 0.5. Okay, now if they are independent, so for independent events, the chance of them both happening, there's two ways of kind of doing this, probability of A and B would be equal to the probability of A multiplied by the probability of B. So we could do 0.6 multiplied by 0.5, which gives us 0.3. Okay, so they are independent. Okay, the other way of doing it is using that formula. So probability of B given A is equal to the probability of A and B divided by the probability of A. So probability of A and B is 0.3, probability of A is 0.6, and if the probability of B given A is the same, then yes, they're independent. So 0.3 divided by 0.6, it's going to be a half, isn't it? Is a half. Okay, so the probability of B at a half is equal to the probability of B given that A has happened, right? So they're exactly the same as each other, shown two ways there. Okay, yeah, so it can also be used for that.